When you look up at the night sky, it feels calm and simple. The darkness stretches quietly above you, and small points of light shine softly in the distance. For most people, this moment brings peace, but for thousands of years, it has also brought a question that refuses to go away. How many stars are really out there? At first, the question sounds easy. You might think the answer is just a big number written in a book somewhere. But the moment you try to understand it, the question becomes deeper. The stars are not lined up for counting. They are not fixed dots on a flat surface. They are spread across space and time, hidden by distance, dust, and the limits of human vision. The sky you see tonight is not the universe as it is now. It is the universe as it was in the past. Some of the light reaching your eyes began its journey before cities existed, before civilizations formed, before humans even walked the earth. In that sense, looking at the stars is like looking into history. For most of human existence, stars were mysteries. People created stories to explain them. They saw animals, heroes, and gods in the patterns of light. These stories helped people remember seasons, navigate oceans, and understand their place in the world. But they did not answer the question of how many stars there were. That question required something else. It required tools, patience, and a willingness to accept that some answers would never be exact. Today, scientists can estimate the number of stars in the universe, but even now, the answer is not a clean number. It is a range. It is a carefully reasoned guess built from observation, physics, and logic. And yet, even knowing that, the question still matters. Because it pushes us to understand scale. It pushes us to recognize how small our everyday experience is compared to the cosmos. And it reminds us that the universe is far larger and richer than what we can see with our eyes. To understand how many stars exist, we must start with something very basic. We must understand what a star actually is. A star is not just a point of light. It is a massive ball of gas, mostly hydrogen, held together by gravity. Deep inside the star, pressure is so intense that atoms are forced together. When hydrogen atoms combine to form helium, energy is released. That energy moves outward and eventually escapes as light and heat. This process is called nuclear fusion. It is the reason stars shine. Our sun is a star. It feels special to us because it is close. It warms our planet, drives weather, and makes life possible. But in the universe, the sun is ordinary. It is one star among countless others, following the same physical rules as stars everywhere. Stars come in many forms. Some are much smaller than the sun and glow faintly. Some are far larger and brighter, burning their fuel quickly. Some live for billions or even trillions of years. Others burn out in a few million years and end their lives in violent explosions. These differences matter when we talk about counting stars. We are not counting identical objects. We are counting a wide family of stars, each with different brightness, size, and lifespan. Another key point is that stars are not always visible. In fact, most stars are invisible to the naked eye. Some are too far away. Some are hidden behind clouds of gas and dust. Some are faint and small. Some may no longer exist even though their light is still traveling through space. This leads to an important idea. When we see a star, we are not seeing it as it is right now. We are seeing it as it was when its light began the journey toward Earth. Light has a speed limit. It cannot travel faster than that. So distance becomes time. A star that is 1,000 light years away appears to us as it was 1,000 years ago. A star that is 1,000,000 light years away appears as it was 1,000,000 years ago. This means the night sky is a mix of different moments in history. Some stars you see tonight may already be gone, and many stars that exist right now are still invisible to us. Because of this, counting stars is not like counting objects in a room. It is more like estimating how many fish live in an ocean when you can only see the surface. For a long time, humans could only see stars with their eyes. Under perfect conditions, far from city lights, a person can see about 2,000 to 3,000 stars in the sky at one time. Over the course of a year, combining views from both hemispheres, that number rises to about 6,000. That is all. 6,000 visible stars out of a universe that contains numbers so large they barely fit into language. This alone tells us something important. Almost everything in the universe is hidden from us. The invention of the telescope changed that. When early astronomers pointed telescopes toward the sky, the universe suddenly became crowded. The Milky Way, once seen as a faint glowing band, was revealed to be made of countless individual stars. With every improvement in telescope technology, more stars appeared. Larger mirrors collected more light. Better sensors detected fainter objects. Space telescopes avoided Earth's atmosphere and saw deeper into darkness. Each time, the universe expanded again. But even the most powerful telescopes cannot see everything. Dust blocks light, distance weakens it, and beyond a certain point, light has simply not had enough time to reach us. To go further, astronomers needed a new approach. Instead of counting individual stars, they began to think in terms of systems. Stars are not scattered randomly across space. Most belong to galaxies. A galaxy is a massive collection of stars, gas, dust, and dark matter, all bound together by gravity. Our home galaxy is called the Milky Way. It contains stars, planets, and vast regions of empty space, all moving together through the universe. Understanding how many stars exist in the universe begins with understanding how many stars exist in a typical galaxy. But even that is not simple. We live inside the Milky Way. We cannot step outside and count its stars directly. Much of the galaxy is hidden from view by dust clouds. The center is especially dense and difficult to observe. So how do scientists estimate the number of stars in our galaxy? They begin with regions where stars are easier to see. They count stars in those regions and measure how dense they are. They study how star density changes as you move toward or away from the galactic center. They measure the total brightness of the galaxy and connect that brightness to star populations, accounting for the fact that a few bright stars can outshine many faint ones. They study how stars move. Their motion reveals how much mass the galaxy contains. By subtracting gas and dust, scientists estimate how much mass belongs to stars. They also use infrared light to see through dust, revealing stars that are invisible in normal light. Each method has limits. But when different methods point to similar results, confidence grows. Today, most estimates suggest that the Milky Way contains between 100 billion and 400 billion stars. Even the lower end of that range is difficult to imagine. 100 billion stars means 100 billion suns, each with its own story, its own lifespan, its own place in space. And this is just one galaxy. For a long time, people believed the Milky Way was the entire universe. Every star belonged to it. The idea of other galaxies did not exist. That belief changed when astronomers discovered that faint, cloudy objects in the sky were not nearby gas clouds, but entire galaxies far beyond our own. Each of those galaxies contains its own stars, its own systems, its own history. Once that realization took hold, the scale of the universe expanded beyond anything humans had ever imagined. If one galaxy can contain hundreds of billions of stars, and if the universe contains many galaxies, then the total number of stars must be far beyond direct counting. This realization sets the stage for everything that follows, because from this point forward, the question is no longer about what we can see with our eyes. It is about how far human understanding can reach into the vast darkness of space. When people imagine the universe, they often imagine what they can see. The night sky feels like a map of reality. The stars above us seem to represent what exists out there. But this feeling is deeply misleading. What we see is not the universe. It is only the smallest visible surface of it. The human eye is a remarkable tool, but it was never designed to explore space. It evolved to help us survive on Earth, to recognize faces, detect movement, and sense light during the day and night. compared to the scale of the universe, our vision is extremely limited. On a perfectly clear night, far away from city lights, with no moon in the sky, a human can see about 2,000 to 3,000 stars at once. This number surprises many people because the sky feels much more crowded than that. But the feeling comes from darkness, not quantity. The mind fills in what it cannot see. If you add together all the stars visible from the northern hemisphere and the southern hemisphere across the entire year, the total number of stars visible to the naked eye is about 6,000. That is the absolute maximum. 6,000 stars are all humans could see for nearly all of history. Every myth, every constellation, every ancient calendar was built using this tiny sample of the universe. And yet, those 6,000 stars shaped civilizations. They guided travelers across deserts and oceans. They marked seasons for farming. They became symbols of gods, spirits, and destiny. People believed the sky was fixed and complete, like a painted ceiling above the world. This belief lasted for thousands of years because nothing challenged it. But the truth is that those 6,000 stars represent almost nothing compared to what exists. Why can we see so few? The first reason is distance. Light spreads out as it travels. The farther it goes, the weaker it becomes. Even the brightest stars become invisible when they're far enough away. Most stars simply do not send enough light to reach our eyes across the vast distances of space. The second reason is size and brightness. Most stars in the universe are small and faint. They glow quietly. They do not shine with the brilliance of giant stars. These faint stars make up the majority of the stellar population, but they are nearly impossible to see without powerful instruments. The third reason is dust. Space is not perfectly clear. Clouds of gas and dust float between stars. These clouds block visible light, hiding stars behind them. Entire regions of our own galaxy are invisible to the naked eye because of dust. The fourth reason is Earth itself. Our planet's atmosphere scatters light. It blurs faint objects. It limits clarity. Even on the clearest nights, the atmosphere reduces how much of the universe we can see. And finally, there is light pollution. Artificial light from cities floods the sky and overwhelms faint starlight. For billions of people today, the night sky contains only a handful of stars. Some people grow up never seeing the Milky Way at all. This loss of darkness has created a strange situation. Humanity knows more about the universe than ever before, yet most people see less of it with their own eyes than ancient humans did. This is why telescopes became so important. The moment telescopes were invented, the universe changed. Early telescopes were simple by today's standards, but even they revealed something shocking. The Milky Way was not a smooth cloud. It was made of countless stars packed together. What looked like emptiness suddenly became crowded. As telescopes improved, astronomers saw deeper and deeper into space. Stars appeared where none were visible before. Entire star clusters emerged from darkness. Each improvement revealed a simple truth. The universe is filled with stars that our eyes cannot detect. Modern telescopes can see stars billions of times fainter than what the human eye can see. Space telescopes can detect light across many wavelengths, including infrared, which passes through dust and reveals hidden stars. With these tools, astronomers began to understand something crucial. The stars we see with our eyes are not typical. They are the brightest and closest ones. They are the highlights, not the full picture. Most stars are smaller, cooler, and dimmer than the sun. These stars, often called red dwarfs, burn slowly and live for extremely long periods. They are the most common type of star in the universe, but because they are faint, very few are visible without telescopes. This creates an illusion. The night sky makes it seem like stars are rare and spread far apart. In reality, space is filled with stars, but most of them are quietly glowing beyond our perception. Another illusion comes from perspective. When you look up, stars appear evenly scattered across the sky, but they are not. Most of the stars you see belong to a thin, disc-shaped structure called the Milky Way galaxy. When you look toward the plane of this disc, you see more stars packed together. When you look away from it, the sky appears emptier. This is why the Milky Way appears as a glowing band across the sky. It is not a cloud. It is our sideways view through the dense center of our own galaxy. Ancient people noticed this band and named it, but they did not understand what it was. Today, we know it is a direct visual clue that we live inside a galaxy. This realization changed astronomy forever. Once scientists understood that stars belong to a galaxy, they could stop thinking of the sky as a flat surface and start thinking in 3 dimensions. They could begin to ask new questions. How big is our galaxy? How many stars does it contain? And if there are other galaxies, how many stars do they contain? But before answering those questions, astronomers needed to understand the limits of what they were seeing. Even the most powerful telescopes cannot see every star in the Milky Way. Dust blocks light. Dense regions hide stars behind stars. The center of the galaxy is especially difficult to observe. To overcome this, astronomers use indirect methods. They observe how stars move under gravity. The speed of their motion reveals how much mass exists in a region, even if that mass is hidden. If stars are moving faster than expected, it means more matter is present. They also study gas clouds. Gas flows trace gravitational structures. Where gas gathers, stars often exist or will form. Infrared surveys allow scientists to see stars hidden behind dust. Radio observations reveal structures invisible in visible light. By combining all these methods, scientists can estimate how many stars exist even when they cannot see them directly. This approach represents a major shift in human thinking. Instead of trusting only what we see, we trust what physics tells us must be there. This is how astronomy moved from stargazing to science. Still, even with all this technology, our view is limited. The universe has a boundary called the observable universe. This boundary exists because light has a finite speed and the universe has a finite age. Light from regions beyond this boundary has not had enough time to reach us. This means there are stars and galaxies that exist beyond our view, not because they are too faint, but because their light has not arrived yet. So even the best telescopes show us only a portion of reality. This idea is difficult to accept. It means that no matter how advanced our technology becomes, there will always be parts of the universe we cannot see. And yet, even within this limited view, the number of stars is already beyond imagination. This realization leads to a quiet truth. Everything humans have ever seen, touched, or experienced exists within a tiny bubble of a much larger universe. The stars visible to our eyes are like grains of dust floating on the surface of an ocean. Understanding this does not make us insignificant, it makes our curiosity extraordinary. Because despite these limits, humans found ways to estimate what lies beyond sight. They learned to count stars they could not see by understanding patterns, motion, and light. This brings us to the next step in the journey. If stars belong to galaxies, and if we can estimate how many stars exist in one galaxy, then the key to understanding how many stars exist in the universe lies in understanding galaxies themselves. To understand how many stars exist in the universe, we must slow down and stay close to home for a moment. Before counting the stars beyond our galaxy, we need to understand the place where we live. The Milky Way is our cosmic neighborhood. Everything we see in the night sky with our eyes belongs to it. For a long time, humans did not realize this. The Milky Way appeared as a faint, white band stretching across the sky. People gave it names and stories, but no one knew what it truly was. It was only when telescopes became powerful enough that scientists realized the truth. That glowing band was not a cloud. It was a dense collection of stars, packed together in a structure far larger than anyone had imagined. The Milky Way is a galaxy. It is not small. It is not simple. It is a massive system containing stars, planets, gas, dust, and something invisible called dark matter, all held together by gravity. The Milky Way has a shape. It is not a perfect circle, but it is roughly a flat disk with a bulging center. From edge to edge, it is about 100,000 light-years wide. This number alone is difficult to grasp. A light-year is the distance light travels in 1 year. Light moves incredibly fast, yet it would take 100,000 years just to cross our galaxy. The galaxy is not thin like a sheet of paper. It has thickness, but compared to its width, it is still very flat. Most of the stars are concentrated in this disk, especially along long spiral arms that stretch outward from the center. At the very center of the Milky Way lies a dense core filled with stars packed tightly together. Hidden within this core is a supermassive black hole. It does not shine like a star, but its gravity affects everything around it. Stars near the center orbit rapidly, pulled by its immense mass. Our solar system does not live near this center. We are located far out in one of the spiral arms, in a quieter region of the galaxy. This position is important. It gives us a relatively calm environment and a clearer view of the universe beyond. If we lived closer to the center, the sky would be brighter and more crowded, but much harder to study. Because we live inside the Milky Way, studying it is surprisingly difficult. Imagine trying to understand the shape of a forest while standing deep inside it. Trees block your view. Distances are hard to judge. You cannot step outside and look back. Astronomers face the same problem with the Milky Way. Large clouds of gas and dust block visible light, especially toward the center of the galaxy. Entire regions are hidden from view. This makes direct observation impossible. So how do scientists study the Milky Way? They use many methods, each revealing a different piece of the puzzle. One method is star counting in small regions. Astronomers select areas of the sky where dust is thin and stars are visible. They count how many stars exist within a known volume of space. Then they measure how star density changes with distance. Another method involves brightness. The total light coming from the Milky Way can be measured, but brightness alone is misleading. A few bright stars can outshine millions of faint ones, so astronomers must understand the types of stars producing the light. They study star populations. They learn how common different types of stars are. They determine how many faint stars likely exist for every bright one we see. Motion provides another powerful clue. Stars orbit the center of the galaxy. By measuring how fast they move, scientists can estimate how much mass the galaxy contains. Faster motion means stronger gravity, which means more mass. This mass includes stars, gas, dust, and dark matter. By estimating how much mass belongs to gas and dust, scientists can infer how much mass belongs to stars. Infrared astronomy plays a key role here. Infrared light passes through dust more easily than visible light. When astronomers observe the Milky Way in infrared, stars hidden for centuries suddenly appear. These infrared surveys revealed something surprising. The Milky Way is far more crowded than visible light suggests. Many stars are small, faint and hidden, but they are everywhere. From all these methods combined, scientists arrive at a range. The Milky Way contains somewhere between 100 billion and 400 billion stars. This range is wide, but it reflects honesty. The galaxy is complex, dynamic, and partially hidden. Precision has limits. Even so, the scale is overwhelming. 100 billion stars is a number beyond everyday meaning. If you tried to count one star per second without stopping, it would take more than 3,000 years to reach 100 billion. And remember, this is only one galaxy. Another important detail often surprises people. Most stars in the Milky Way are not like the Sun. The Sun is a medium-sized star. It shines steadily and supports life on Earth. But stars like the Sun are not the most common type. The most common stars are red dwarfs. They are smaller, cooler, and much fainter. They burn their fuel slowly and can live for trillions of years, far longer than the current age of the universe. Because they are faint, very few red dwarfs are visible to the naked eye, yet they dominate the galaxy by number. This means that the Milky Way is filled with stars that quietly glow, unnoticed, forming the backbone of the galaxy's population. The galaxy also contains star clusters. Some are ancient, formed early in the galaxy's history. These clusters can contain hundreds of thousands of stars, tightly packed together. Other clusters are young. They form when gas clouds collapse and create many stars at once. Over time, these clusters slowly drift apart as gravity weakens their bonds. By studying clusters, astronomers learn how stars form and how many stars typically emerge from a single cloud of gas. The Milky Way is not static. It is alive with motion. Stars orbit the center. Gas flows along spiral arms. New stars are born in glowing clouds. Old stars die and leave behind remnants. Collisions also shape the galaxy. Smaller galaxies have merged with the Milky Way in the past, adding their stars to our own. Even today, the Milky Way is slowly interacting with nearby galaxies. This means the number of stars in the Milky Way has changed over time and will continue to change. Some stars are lost when galaxies collide and stars are thrown into intergalactic space. Others are gained through mergers. Star formation rises and falls depending on gas supply. Still, despite all this change, the estimate of hundreds of billions of stars remains stable. Different techniques, different data, same general answer. That consistency gives scientists confidence. Now comes a crucial realization. For centuries, humans believed the Milky Way was the entire universe. Every star belonged to it. Everything that existed was inside this one vast system. This belief shaped philosophy, religion, and science. Then in the early 20th century, astronomers made a discovery that completely changed our understanding of reality. They realized that faint cloudy objects in the sky were not nearby gas clouds. They were entire galaxies, far beyond the Milky Way, each one containing its own stars. These galaxies were so distant that their stars blended together into a soft glow. But distance did not make them small. It only made them appear that way. Suddenly the universe expanded. The Milky Way was no longer everything. It was one galaxy among many. This discovery did more than add objects to the universe. It multiplied the scale of everything we thought we knew. If our galaxy contains hundreds of billions of stars, and if there are other galaxies like it, then the number of stars in the universe must be far larger than even the Milky Way alone suggests. This realization forced scientists to think differently. They could no longer focus only on stars. They had to focus on galaxies. They had to ask new questions. How many galaxies exist? How big are they? How many stars does each one contain? Only by answering those questions could anyone hope to estimate how many stars exist in the universe. And that takes us beyond our home, beyond the Milky Way, into deep space, where galaxies appear as tiny islands of light drifting through a vast cosmic ocean. Once astronomers understood that the Milky Way was not the entire universe, everything changed. The sky was no longer a single system filled with stars. It became something far larger and far more complex. The universe turned into a vast space, filled with many galaxies, each one carrying its own collection of stars. At first, this idea was difficult to accept. For centuries, people believed that everything they saw belonged to the Milky Way. The faint cloudy shapes visible through early telescopes were assumed to be nearby objects, part of our own galaxy. No one imagined they could be separate galaxies, each as large as our own. The breakthrough came when astronomers began measuring distances more carefully. They discovered that some of these faint clouds were far too distant to belong to the Milky Way. They were millions of light years away. That meant they were not small nearby objects. They were enormous systems of stars far beyond our galaxy. This realization expanded the universe overnight. Suddenly, the Milky Way was just one galaxy among many. The stars we see in the sky were no longer the full story. They were only the stars in our local island of the universe. Once this door opened, astronomers began to search for more galaxies. As telescopes improved, the number of known galaxies grew rapidly. What once looked like empty darkness began to fill with faint shapes. Each shape was not a star, but a galaxy made of billions or even trillions of stars. Galaxies come in many forms. Some are large and graceful, with spiral arms wrapping around a bright center. These spiral galaxies often contain young stars, glowing gas clouds, and active regions of star formation. The Milky Way belongs to this group. Either galaxies are rounder and smoother. These galaxies are packed tightly with stars and often contain older star populations. They have little gas and dust, which means fewer new stars are forming inside them. There are also irregular galaxies. These have no clear shape. Many of them have been stretched or distorted by collisions with other galaxies. Gravity reshapes them over time, pulling stars into strange patterns. The size of a galaxy matters greatly when estimating stars. Small galaxies may contain only a few million stars. These are tiny compared to the Milky Way. Large galaxies, on the other hand, can contain hundreds of billions or even trillions of stars. Some of the largest galaxies sit at the centers of galaxy clusters and grow by merging with smaller galaxies over time. This wide range makes counting stars across the universe more complicated. You cannot simply count galaxies and multiply by one number. Each galaxy has its own story, its own size, and its own star population. To solve this problem, astronomers turned to deep sky surveys. They chose small regions of the sky that appeared nearly empty. Then they observed those regions for long periods of time, collecting as much light as possible. These long observations revealed something astonishing. In areas that looked completely dark to the naked eye, telescopes uncovered thousands of galaxies. Each tiny point of light was not a star, but an entire galaxy far away. One famous deep sky image showed thousands of galaxies packed into a patch of sky no larger than a grain of sand held at arm's length. That image revealed galaxies of many shapes, sizes, and distances. Some of the light in that image had traveled for billions of years before reaching Earth. This changed how scientists thought about space. Empty space was no longer empty. It was full of galaxies hidden only by distance and faintness. By repeating these surveys in different directions, astronomers began estimating how many galaxies exist in the observable universe. Early estimates suggested around 100 billion galaxies. Later studies, using more advanced data, suggested the number could be even higher. Some modern estimates suggest there may be several hundred billion galaxies, and possibly even more, within the observable universe. However, astronomers are cautious. Many galaxies are small and faint. Some are difficult to detect, even with powerful telescopes. This means galaxy counts are likely incomplete. Still, even conservative estimates lead to astonishing conclusions. If there are hundreds of billions of galaxies, and if each galaxy contains millions to trillions of stars, then the total number of stars becomes unimaginably large. To handle this, scientists use averages. They study nearby galaxies in detail, where individual stars can be counted more easily. They measure how many stars different types of galaxies tend to contain. They then apply these averages to distant galaxies that cannot be studied in the same detail. This method is not perfect, but it is the best approach available. When astronomers combine galaxy counts with star estimates, they arrive at a number that is difficult to even speak aloud. The observable universe likely contains a few sextillion stars. That is a number with more than 20 zeros. At this scale, exact numbers lose meaning. What matters is the order of magnitude. Whether the number is 2 sextillion or 5 sextillion does not change the bigger picture. the universe contains more stars than the human mind can comfortably imagine. And this estimate only applies to the observable universe. The observable universe is limited by the speed of light and the age of the universe. Light from beyond a certain distance has not had enough time to reach us since the beginning of cosmic expansion. This does not mean the universe ends there. It only means our view does. Beyond the observable universe, space may continue. Galaxies may continue. Stars may continue, but we have no way to observe them. So when scientists talk about how many stars exist, they're talking about how many stars we can possibly detect or infer from our position in space and time. The true total number of stars in the entire universe could be far larger, or it could be limited in ways we do not yet understand. This uncertainty is not a flaw, it is part of science. Another important point is time. When we observe distant galaxies, we are seeing them as they were long ago. Some galaxies we observe are billions of years younger than the Milky Way was when we see it today. Some stars in those galaxies may no longer exist. Others may not have formed yet. So the universe we observe is not a snapshot of one moment. It is a layered view of different eras of cosmic history. This means the number of stars visible in the universe changes depending on when and where you look. Despite these complications, astronomers continue refining their estimates. New telescopes are designed to see deeper into space and further back in time. Each new observation adds detail and sometimes challenges previous assumptions. Yet even as numbers shift slightly, the central truth remains unchanged. The universe is filled with galaxies. Each galaxy is filled with stars, and the total number of stars is far beyond anything humans can count directly. At this point in the journey, it becomes clear that counting stars is not really about numbers. It is about understanding structure. Stars form galaxies. Galaxies form clusters. Clusters form large-scale patterns across the universe. Matter gathers into filaments and walls, leaving behind vast empty regions. The universe is not random chaos. It has shape and order on enormous scales. This order allows scientists to estimate what they cannot see. It allows them to connect small observations to vast conclusions. And yet, even with this understanding, something remains humbling. Every galaxy we see is only a tiny part of the universe. Every star we count is one among sextillions, and every answer we find opens new questions. As we move forward, the question shifts once again. If the universe contains so many stars, and if stars are constantly being born and dying, then the number of stars is not fixed. It evolves. To truly understand how many stars exist, we must understand how the universe changes over time. At this point in the journey, the question of how many stars exist becomes inseparable from another idea that sounds simple, but changes everything once you understand it. That idea is the observable universe. When people hear the word universe, they often imagine everything that exists, endless space, stretching in all directions, filled with galaxies and stars. But science makes an important distinction. There is the universe, and then there is the observable universe. The observable universe is not the entire universe. It is only the part of the universe that we can see from Earth. This difference matters more than it first appears. The reason the observable universe exists has nothing to do with technology and everything to do with time. Light does not travel instantly. It moves at a fixed speed. And the universe has a finite age. This means there is a limit to how far light has been able to travel since the universe began. If a galaxy is so far away that its light has not yet reached Earth, then it exists, but it is not observable to us. No telescope, no matter how powerful, can see it. Not because it's too faint, but because its light is still on the way. So when scientists talk about counting stars, they are counting stars within this observable boundary. They are counting stars whose light has had enough time to reach us. This immediately places a limit on everything we can know. The observable universe has a radius of about 46 billion light-years. This number often confuses people because the universe itself is about 13.8 billion years old. How can we see something 46 billion light-years away if the universe is not that old? The answer lies in expansion. The universe is expanding, and it has been expanding since its beginning. Space itself stretches. As light travels through space, the space it moves through continues to expand. This means the distance between us and the source of the light has grown while the light was traveling. So the galaxies we see at the edge of the observable universe are much farther away now than they were when their light began its journey. This expansion means that the observable universe is much larger than a simple calculation would suggest. Inside this enormous sphere lies everything we can ever observe. All the galaxies we have detected, all the stars we can estimate, all the cosmic structures we can study. Beyond it, there may be more galaxies, more stars, possibly far more than within the observable universe, but we have no way to know. This is why the phrase, "how many stars exist in the universe," must always be understood carefully. Scientifically, it means how many stars exist in the observable universe. Now think about what this means for star counting. We are not counting stars in a static picture. We are counting stars across space and time. When we look at nearby stars, we see them as they are now, or almost now. When we look at distant galaxies, we see them as they were billions of years ago. Some of the stars we count may no longer exist. Some stars that exist today may not be counted because their light has not arrived yet. So the observable universe is like a layered record of cosmic history. Close by, we see the present. Far away, we see the past. This layered view creates challenges, but it also creates opportunities. It allows astronomers to study how the universe changed over time, how stars formed, how galaxies grew, and how star populations evolved. One of the most important discoveries from observing the distant universe is that star formation was not constant. There was a time when stars formed much more rapidly than they do today. This period occurred several billion years after the universe began. During that era, galaxies were rich in gas and actively forming new stars. As time passed, gas supplies were used up or scattered. Star formation slowed. Many galaxies became quieter, dominated by older stars. This means the observable universe contains stars from many different eras. Some stars formed very early and have already died. Some formed later and still shine today. When scientists estimate the total number of stars, they must account for this changing history. Another important idea is that the observable universe contains structure. Galaxies are not spread evenly through space. They form groups, clusters, and vast networks. These networks create enormous filaments of galaxies separated by large empty regions called voids. This structure matters because it affects how stars are distributed. Some regions of the observable universe are rich in galaxies and stars, others are sparse. When astronomers perform deep surveys, they carefully select different regions of the sky to avoid bias. They do not want to accidentally count an unusually crowded or unusually empty area and assume it represents the whole universe. This careful approach allows them to estimate average galaxy density and star density across the observable universe. Deep surveys reveal something remarkable. As telescopes observe farther and farther into space, galaxies do not suddenly disappear. They continue to appear, faint and distant, stretching back toward the early universe. This tells us that galaxies formed relatively early and that star formation began long ago. By combining deep surveys with models of galaxy evolution, scientists can estimate how many galaxies exist at different distances and times. Once galaxy numbers are estimated, the next step is estimating stars. This process involves several layers of inference. First, astronomers estimate the number of galaxies in the observable universe. This number is uncertain, but it likely falls in the hundreds of billions. Second, they estimate how many stars different types of galaxies contain. Large spiral galaxies like the Milky Way contain hundreds of billions of stars. Smaller galaxies contain fewer. Giant elliptical galaxies can contain even more. Third, they combine these estimates using averages weighted by galaxy type and size. This approach does not give an exact answer, but it gives a reliable range. The result is a number so large that it defies intuition: a few sextillion stars. That is a 1, followed by more than 20 zeros. At this scale, comparisons become necessary. People often ask whether there are more stars than grains of sand on Earth. While the comparison is not exact, it highlights the scale involved. The number of stars in the observable universe likely rivals or exceeds the number of grains of sand on all the world's beaches. But even this comparison falls short. Stars are not evenly spread like sand. They are separated by vast distances. They shine, move, and change. Each one is a dynamic system, not a static grain. Another important point is that the observable universe is not fixed. As time passes, the observable boundary changes. Light from more distant regions continues to arrive. At the same time, expansion causes some galaxies to move away so fast that their light will never reach us in the future. This creates a strange situation. There are galaxies we can see today that future observers will never see. There are also galaxies that future observers may see that we cannot. So the observable universe depends on when you observe it. This makes the question of star counts even more subtle. The number of stars we can observe is not just a function of space, but of time. This does not mean star counts are meaningless. It means they are context-dependent. Science accepts this. It does not try to force the universe into simple answers. Instead, it describes reality as accurately as possible, even when that reality is complex. Another layer to consider is dark matter and dark energy. While dark matter does not form stars, it plays a crucial role in shaping galaxies and clusters. It provides the gravitational framework that allows gas to gather and stars to form. Dark energy, on the other hand, drives the expansion of the universe. It influences how galaxies move apart over time, and therefore affects which stars will remain observable. These invisible components dominate the universe by mass and energy, yet stars, though a small fraction of the universe's total content, dominate what we see. This contrast is striking. The universe is mostly invisible, yet filled with light. As we consider the observable universe, another realization emerges. Even though the number of stars is enormous, stars make up only a small fraction of the universe's total matter and energy. Most of the universe is something else entirely. This tells us that stars are rare in one sense and abundant in another. Rare compared to the vast emptiness of space, yet abundant beyond human comprehension. This dual nature is one of the most fascinating aspects of the cosmos. It also reminds us why counting stars is not just about curiosity. Stars shape galaxies, they create heavy elements, they influence the formation of planets and the possibility of life. Every atom heavier than hydrogen and helium was created inside stars or during their deaths. The universe we experience is a product of stellar activity. So when we estimate how many stars exist, we are also estimating how much complexity the universe can produce. As telescopes continue to improve, our view of the observable universe will become sharper. New instruments will detect fainter galaxies and older stars. Estimates will change slightly, but the overall picture will remain. The universe is vast, it is ancient, and it is filled with stars beyond direct counting. At this stage, the question begins to shift again. If the observable universe contains such an enormous number of stars, how do scientists actually turn this knowledge into a final estimate? How do they combine all these observations into a single number that, while imperfect, still tells us something real? To answer that, we need to look closely at how scientists estimate the total number of stars. At this stage, the universe may already feel overwhelming. Billions of galaxies, each galaxy filled with billions of stars, numbers that stretch far beyond daily experience. So the natural question becomes this: how do scientists actually turn all of this into a number at all? How do you estimate something you cannot see completely, cannot touch, and cannot count directly? The answer is not a single method. It is a careful process built from many smaller steps, each one grounded in observation and physical laws. Scientists do not guess. They build estimates layer by layer, testing each assumption along the way. The first step is understanding what can be observed clearly. Astronomers begin with nearby space. In our own galaxy and in nearby galaxies, individual stars can be studied in detail. Their brightness, color, movement, and distribution can be measured directly. This gives scientists a solid foundation. From these nearby regions, astronomers learn how stars are distributed. They learn how many stars exist in a given volume of space. They learn which types of stars are common and which are rare. They learn how brightness relates to star numbers. This local knowledge becomes the key to estimating what cannot be seen clearly at greater distances. The next step involves galaxies. Astronomers study nearby galaxies where individual stars can still be resolved. They count stars in these galaxies and measure the total light they produce. This allows scientists to connect total brightness to star populations. Once this connection is understood, it can be applied to distant galaxies. In distant galaxies, individual stars blend together. They cannot be counted one by one. Instead, astronomers measure the total light coming from the galaxy. Using what they learned from nearby galaxies, they estimate how many stars must be present to produce that amount of light. This method works because stars follow predictable physical rules. A galaxy filled with many faint stars produces a different kind of light than a galaxy dominated by fewer bright stars. By analyzing the color and brightness of a galaxy, astronomers can infer the types and numbers of stars inside it. Another important tool is the concept of stellar populations. Not all stars form at the same time. Galaxies contain mixtures of young stars and old stars. Young stars are often brighter and bluer. Old stars are dimmer and redder. The mix of these stars affects the galaxy's overall appearance. By studying galaxy light carefully, astronomers can estimate how many stars of different types are present. Motion adds another layer. Stars orbit the centers of galaxies under gravity. By measuring how fast stars and gas move, scientists can estimate how much mass the galaxy contains. This mass includes stars, gas, dust, and dark matter. Dark matter does not shine, but it reveals itself through gravity. By subtracting the estimated mass of gas, dust, and dark matter, astronomers can estimate how much mass belongs to stars. This mass-based estimate provides a check on light-based estimates. If both methods agree, confidence increases. Infrared observations add further clarity. Dust blocks visible light, hiding many stars. Infrared light passes through dust more easily. When astronomers observe galaxies in infrared, they often discover far more stars than visible light suggests. By combining visible and infrared data, astronomers get a more complete picture of star populations. All of these methods work well for nearby and moderately distant galaxies. But what about the most distant galaxies, near the edge of the observable universe? For these galaxies, astronomers rely on deep surveys. Deep surveys observe small patches of sky for long periods. They collect faint light from distant galaxies and measure how many galaxies appear at different brightness levels. From this data, astronomers estimate how galaxy numbers change with distance and time. They then combine this with models of galaxy formation and evolution. These models are based on physics. They simulate how gas collapses into stars, how galaxies merge, and how star formation changes over time. The models are tested against observations. When they match what we see, scientists gain confidence in using them to fill in gaps. This combination of observation and modeling allows astronomers to estimate the total number of galaxies in the observable universe. Once the number of galaxies is estimated, the next challenge is estimating stars per galaxy. Here, averages become essential. Astronomers know that galaxies come in many sizes. Some are tiny, some are enormous. So instead of assuming every galaxy is like the Milky Way, scientists study the distribution of galaxy sizes. They determine how common small galaxies are compared to large ones. They estimate how many stars each type typically contains. Small galaxies may contain millions or tens of millions of stars. Medium galaxies contain billions. Large spiral galaxies contain hundreds of billions. Giant elliptical galaxies may contain trillions. By combining these distributions, astronomers calculate an average number of stars per galaxy, weighted by how common each type is. This weighted average is crucial. Small galaxies are more common than large ones, but large galaxies contain far more stars. Both factors must be considered. Once this average is established, astronomers multiply it by the estimated number of galaxies. This multiplication produces a staggering result. The observable universe likely contains a few sextillion stars. At this scale, even scientists must pause. Numbers like this are not intuitive. They are abstract. They are beyond direct experience. That is why scientists often speak in ranges rather than exact values. The uncertainty comes from several sources. Some galaxies are too faint to detect. Some stars are hidden by dust. Some assumptions about star formation may change with new data. But even with these uncertainties, the order of magnitude remains stable. Whether the number is 2 sextillion or 10 sextillion does not change the main conclusion. The universe contains an enormous number of stars, far beyond anything humans can count directly. Another important point is that stars are not evenly distributed through time. The observable universe shows us stars from different eras. Some stars formed early and died long ago. Some formed recently and still shine brightly. Some will form in the future. So when scientists estimate star numbers, they must consider both living stars and stars that once existed but no longer shine. In many cases, star counts focus on stars that exist at a given moment in cosmic time, even though observations mix different eras. This adds complexity but does not invalidate the estimates. Another subtle issue is definition. What counts as a star? Do we count only stars currently producing light through fusion? Or do we include stellar remnants like white dwarfs, neutron stars, and black holes that were once stars? Different studies answer this differently. Some estimates include only active stars. Others include remnants. This can change the total number slightly, but again, not enough to alter the big picture. One of the most remarkable things about this process is that it works at all. Humans cannot travel between galaxies. We cannot visit distant stars. We rely entirely on light and physics. Yet using these tools, we can estimate the contents of the universe on the largest scales imaginable. This achievement reflects the power of scientific reasoning. It also highlights the importance of uncertainty. Science does not hide uncertainty, it embraces it. Every estimate comes with error bars, assumptions, and room for revision. This openness allows science to improve over time. As new telescopes come online, such as more powerful space observatories, astronomers will refine their measurements. They will detect fainter galaxies. They will better understand star formation in the early universe. Estimates will change, but they will not suddenly collapse. The universe will remain vast. The number of stars will remain immense. At this point, it is worth stepping back and asking why this matters. Why should we care how many stars exist? The answer is not just curiosity. Stars shape everything we know. They create elements. They power galaxies. They provide energy for planets. They define the structure of the universe. Understanding how many stars exist helps us understand how much complexity the universe can support. It also informs the search for life. If stars are rare, life may be rare. If stars are abundant, the universe may be filled with opportunities for life to arise. Star counts do not answer the question of life directly, but they set the stage. Finally, there is a philosophical dimension. When we understand that the universe contains sextillions of stars, we are forced to rethink scale. Our problems, our worries, our achievements all exist within a tiny corner of a vast cosmic story. This does not make them meaningless, it gives them context. We are part of a universe capable of creating stars by the sextillion, and within that universe, a small species learn to measure, estimate, and wonder. That ability is rare, regardless of how many stars exist. As we approach the end of this exploration, the final pieces come together. Stars are numerous, galaxies are many. The observable universe is vast, and yet everything we know is only a part of something larger. The final step is not about adding more numbers. It is about understanding what these numbers mean for us. When people hear that the universe contains sextillions of stars, the first reaction is often confusion. The second is disbelief. The third is usually a search for something familiar to compare it to, because without comparison, the number has no meaning at all. A sextillion is not something the human mind evolved to understand. We did not grow up dealing with numbers that large. Our daily lives involve tens, hundreds, maybe thousands. Even millions feel abstract. Once we move beyond that, numbers stop feeling real and start feeling symbolic. This is why one comparison has become especially famous. The idea that there may be more stars in the observable universe than grains of sand on all the beaches of Earth. At first, this sounds like poetry or exaggeration, or something said for dramatic effect. But scientists did not arrive at this comparison casually. They arrived at it because both quantities are incredibly large, yet one of them is something we can physically touch. Sand feels endless. When you stand on a beach, every step sinks into countless grains. Each handful contains thousands. Each shoreline stretches for miles. It feels natural to think of sand as uncountable, but sand can be estimated. Scientists have taken small samples of sand, counted how many grains fit into a certain volume, and then scaled that number up using measurements of beaches, coastlines, and deserts. These estimates are rough, but they give a range. The number of grains of sand on Earth is often estimated to be around a few sextillion. Now compare that to star estimates. As we have seen, the observable universe likely contains a few sextillion stars as well. This is where the comparison comes from. Not because the numbers are exactly equal, not because one clearly exceeds the other, but because both live in the same realm of scale. What makes this comparison powerful is not precision, it is perspective. Sand is small, stars are massive. Sand exists on one planet, stars fill the observable universe, and yet, when counted, they occupy a similar range of numbers. This alone is astonishing, but even this comparison does not fully capture the reality. A grain of sand is static. It does not change much over time. A star is dynamic. It forms, it shines, it evolves, and it dies. Each star has a history measured in millions or billions of years. A grain of sand sits next to other grains. Stars are separated by enormous distances. Even in the densest regions of galaxies, the average distance between stars is vast. So while the comparison helps the mind, it also hides important differences. Another common comparison involves people. Imagine that every human who has ever lived was assigned one star. Estimates suggest that around 100 billion humans have ever been born. That is a large number by human standards, but compared to star counts, it is small. Even if every human who ever lived was given a star, there would still be sextillions of stars left unassigned. This comparison highlights something important. Human history, which feels vast and rich to us, occupies only a tiny corner of cosmic scale. Time comparisons tell a similar story. Imagine counting one star per second without stopping. No sleep, no breaks, just counting. In 1 minute, you count 60 stars. In 1 hour, 3,600. In 1 day, about 86,000. In 1 year, about 31 million. At that pace, it would take more than 30,000 years to count 1 billion stars. To count 1 sextillion stars at that rate would take longer than the age of the universe itself. This makes it clear that direct counting is impossible. Not just difficult, impossible. This is why scientists rely on estimation, not enumeration. These comparisons also reveal a deeper issue. The human brain is not good at understanding extreme scale. We can imagine size and distance up to a point. Beyond that, everything starts to blur together. Whether the universe contains 2 sextillion stars or 10 sextillion stars feels the same to us emotionally. Both are far beyond our intuition. This does not mean the difference does not matter scientifically. It does. But emotionally, the mind reaches its limit. This limit is important to acknowledge. It explains why people often feel disconnected when hearing about cosmic numbers. The brain simply has no framework for them. This is not a failure of intelligence. It is a feature of evolution. Humans evolved to navigate environments measured in meters, minutes, and days. Not light years, billions of years, and sextillions of objects. So when we talk about the number of stars in the universe, we are pushing the brain beyond its comfort zone. That discomfort is part of the experience. It is also part of the wonder. Another way to think about star numbers is distribution. Even though the universe contains sextillions of stars, they are spread out over such enormous distances that space still feels empty. This is one of the most confusing ideas about the cosmos. How can something be so full and so empty at the same time? The answer lies in scale. Stars cluster into galaxies. Galaxies cluster into groups and clusters. These clusters form long filaments across the universe. Between these filaments lie vast voids where there are very few galaxies at all. So the universe is not evenly filled, it is structured. In dense regions, stars are abundant. In voids, space is almost empty. This structure means that even with sextillions of stars, most of the universe's volume contains almost nothing. This is another reason why stars feel rare when we look up. Distance also plays a role. The nearest star system beyond the Sun is more than 4 light years away. That distance is so large that even light takes years to cross it. Our fastest spacecraft would take tens of thousands of years. So even though stars are numerous, they are isolated. This isolation has consequences. It limits interaction between star systems. It shapes galaxy dynamics. It influences the likelihood of civilizations ever contacting one another, if they exist. So when we talk about how many stars exist, we are also talking about how those stars are separated. Another important realization comes from change. Stars are not eternal. Every star has a lifespan. Some live for millions of years. Some live for billions. Some may live longer than the current age of the universe, but none live forever. Stars are born from gas clouds. They spend most of their lives fusing hydrogen. Eventually, they run out of fuel. What happens next depends on their size. Small stars fade quietly. Large stars explode violently. Some leave behind dense remnants, like white dwarfs, neutron stars, or black holes. This means the number of active stars in the universe is constantly changing. New stars form, old stars die. So when we say the universe contains sextillions of stars, we are describing a dynamic balance, not a fixed inventory. At any given moment, the universe contains a certain number of shining stars. That number changes over time. Some stars we count existed billions of years ago, but no longer exist today. Some stars that exist today are not yet visible to us. This time delay is crucial. Because of it, the observable universe mixes stars from different eras. Some stars appear in our count even though they are long gone. So the number of stars we estimate is not a photograph of the present. It is a layered record of cosmic history. This leads to a subtle but important idea. The universe is not just large in space, it is large in time. Stars have been forming for billions of years. They will continue forming for billions more. The total number of stars that will ever exist may be larger than the number that exist at any one moment. This distinction matters. When people ask how many stars exist, they often mean how many exist right now. But science often answers a slightly different question. How many stars exist within the observable universe across the eras we can see? This difference is rarely stated explicitly, but it matters. Even with all this complexity, the comparisons remain useful. They remind us that the universe operates on scales far beyond everyday life. They force us to stretch our imagination. They push us to accept that some things cannot be fully visualized, only understood in principle. And this brings us to a quiet realization. The universe does not need to be small enough for us to understand it intuitively. It exists whether or not our minds can picture it. The fact that we can estimate star numbers at all is remarkable. It means we have learned enough about light, gravity, and physics to extend our understanding far beyond our senses. And yet, despite all this knowledge, the universe remains unfinished. Stars are still forming. Galaxies are still evolving. Space is still expanding. The story is not over. To understand how many stars exist, we must also understand how the universe itself changes over time and what the future may hold. Up to now, it may feel like the universe is a giant container already filled with stars, as if someone created a massive space, placed stars inside it, and closed the lid. But that picture is not accurate. The universe is not finished. It is still changing, still moving, still creating. This means the number of stars in the universe is not a fixed number. It never has been, and it never will be. Stars are not permanent objects. They are part of a long process that began billions of years ago and is still unfolding right now. To understand this, we need to think about the universe as something alive in motion, not as a frozen snapshot. In the early universe, there were no stars at all. After the universe began, everything was extremely hot and dense. There were no galaxies, no planets, no light from stars. Space was filled mostly with simple gases, mainly hydrogen and helium. Over time, as the universe expanded and cooled, tiny differences in density began to matter. Some regions contained slightly more matter than others. Gravity slowly pulled matter into these regions, making them denser and denser. Eventually, clouds of gas became massive enough to collapse under their own gravity. As they collapsed, pressure and temperature increased. When conditions became extreme enough, nuclear fusion began. The first stars were born. These first stars were very different from the stars we see today. They were likely massive, extremely bright, and short-lived. They burned through their fuel quickly and died in violent explosions. When they died, they released heavier elements into space. Elements like carbon, oxygen, silicon, and iron did not exist in large amounts before stars formed. Stars created them. This was a turning point in cosmic history. With heavier elements available, later generations of stars could form in more complex ways. Planets became possible. Chemistry became richer. The universe became capable of building complexity. As time passed, stars continued to form inside galaxies. Some galaxies were very active, forming stars rapidly. Others formed stars more slowly. There was a period in cosmic history, often called the peak of star formation. During this time, galaxies across the universe were producing stars at a much higher rate than they do today. The universe was bright and energetic, filled with glowing regions where new stars were being born. Then gradually, things began to slow down. Gas supplies were used up. Powerful stellar winds and explosions pushed gas out of galaxies. Galaxy collisions changed structures. Over billions of years, star formation rates declined. Today, the universe is quieter than it once was. Stars are still forming, but at a slower pace. This has a direct impact on star counts. At any given moment, the universe contains a certain number of active stars, but that number depends on two competing processes: star birth and star death. New stars increase the count. Dying stars decrease it. The balance between these two processes changes over time. In the early universe, star birth dominated. The total number of stars increased rapidly. Later, star birth slowed, and star death became more significant. This means the total number of stars in the universe likely reached a maximum at some point in the past, or may reach one in the future, depending on how long star formation continues. Another factor shaping the future of stars is cosmic expansion. The universe is expanding, and that expansion is accelerating. Galaxies are moving away from each other. Over very long timescales, distant galaxies will move beyond our observable horizon. This does not destroy stars, but it changes what can be observed. In the far future, observers in our galaxy may see fewer and fewer galaxies. The universe will appear emptier, even though stars still exist elsewhere. This means that future star counts based on observation will decrease, not because stars disappear, but because they become unreachable. The observable universe will shrink in practice, even as the universe itself continues to expand. Stars themselves also change. Small stars burn fuel slowly. Some may live for trillions of years, far longer than the current age of the universe. These stars will continue shining long after larger stars have disappeared. Large stars burn fast. They live short lives. They end dramatically. Over time, the universe will become dominated by small faint stars and stellar remnants. White dwarfs, neutron stars, and black holes will become more common than bright, shining stars. Eventually, star formation may stop entirely. Gas will become too spread out. Galaxies will run out of raw material. Gravity will no longer be able to gather enough matter to ignite new stars. When this happens, the number of stars will begin to decline steadily. The universe will enter a long, dark era, dominated by cooling remnants and fading light. This future is unimaginably far away, but it shows something important. The number of stars is not just large, it is temporary. Stars are a phase in cosmic history, not a permanent feature. This idea changes how we think about star counts. When we say the universe contains sextillions of stars, we are describing a particular era, a time when stars are common, galaxies are active, and light fills space. That era will not last forever. This realization also reminds us that the universe we observe today is special. We live during a time when stars are abundant, galaxies are visible, and cosmic history is accessible. Earlier observers would have seen a very different universe. Future observers will see another. So the number of stars we estimate is tied to when we exist. Another important aspect of change is galaxy interaction. Galaxies are not isolated forever. They collide and merge. When galaxies merge, their stars combine into a single system. This does not change the total number of stars, but it changes how stars are grouped. In the future, the Milky Way is expected to merge with the Andromeda Galaxy. When this happens, their stars will mix, forming a new galaxy. This process will not involve stars crashing into each other. Space is too large for that. Instead, gravity will reshape orbits and structures. Star formation may increase briefly during such mergers, then decline again. So even the structure of star populations changes over time. Another subtle factor is stellar recycling. When stars die, they release material back into space. That material can form new stars. This recycling allows star formation to continue longer than it otherwise would. However, recycling is not perfect. Some material is lost to intergalactic space. Some falls into black holes. Over time, usable material becomes scarce, so recycling slows and eventually stops. All of this shows that star counts depend on understanding the universe as a process, not a static object. When scientists estimate how many stars exist, they are not counting something fixed. They are estimating a dynamic system in motion. This is why star counts come with uncertainty. It is not because science is weak. It is because the universe is active. This perspective also helps explain why the question, how many stars exist, has no final answer. There is no moment when the universe stops and allows itself to be counted. The best we can do is estimate within context. And within that context, the conclusion remains powerful. The universe contains an enormous number of stars, far more than the human mind can intuitively grasp, enough to fill billions of galaxies across vast distances. Yet, even with all this abundance, stars are rare in another sense. They occupy only a tiny fraction of the universe's volume. Most of space is empty. Most matter is not in stars. Most energy is not in light. Stars are islands in a vast cosmic sea, and yet those islands shape everything we know. They create elements, they power planets, they allow life to exist. So when we ask how many stars exist, we are really asking how rich the universe is in the ingredients for complexity. This leads naturally to the final reflection. What does this number mean for us? What does it mean to exist in a universe with sextillions of stars? When you step back from the numbers, from the calculations, from the models and estimates, one quiet question remains. What does all of this mean for us? After hearing about sextillions of stars, billions of galaxies, and a universe that stretches far beyond imagination, it is natural to feel small. Many people do. The scale can feel overwhelming, almost uncomfortable. But feeling small is not the same as being unimportant. In fact, understanding how many stars exist changes the way we see ourselves, not by shrinking us, but by placing us into a much larger story. For most of human history, people believed they were at the center of everything. The earth felt solid and permanent. The sky felt distant but arranged around us. The stars seemed like decorations placed for our benefit. Science slowly changed that picture. First, we learned that Earth is not the center of the solar system. Then we learned that the sun is not the center of the galaxy. Then we learned that our galaxy is not the center of the universe. Each step removed us from the center, but each step also expanded our understanding. Today, we know that we live on a small planet orbiting one star among hundreds of billions, in one galaxy among hundreds of billions more. That fact alone could feel discouraging, but there is another way to see it. In a universe this large, the fact that life exists at all is remarkable. The fact that life can ask questions about the universe is extraordinary. Stars are not just lights in the sky, they are the engines that make complexity possible. Without stars, there would be no heavy elements. Without heavy elements, there would be no planets like Earth. Without planets like Earth, there would be no life as we know it. Every atom heavier than hydrogen and helium in your body was created inside a star or during a star's death. The carbon in your cells, the oxygen you breathe, the iron in your blood all came from stars that lived and died long before the sun existed. In that sense, you are not separate from the stars. You are made from them. So when we ask how many stars exist, we are also asking how many opportunities the universe has had to create complexity. With sextillions of stars, the universe has had countless chances to form planets. Many stars have planetary systems. Many of those planets orbit at distances where conditions could allow liquid water. This does not mean life is everywhere. Life depends on many factors we do not fully understand. But it does mean the universe is not short on opportunities. This realization has transformed how scientists think about life beyond Earth. In the past, life elsewhere felt unlikely because the universe was thought to be small. Today, life elsewhere feels possible because the universe is vast. The number of stars does not guarantee life, but it removes the argument that life must be rare simply because there are not enough stars. Another important shift comes from time. The universe is old. Stars have been forming for billions of years. Some stars formed long before the sun. Some will form long after it is gone. Life does not need to appear everywhere at once. It can appear at different times, in different places, under different conditions. So the universe is not just wide, it is deep in time. This means life could have existed long before humans appeared. It could exist now, elsewhere. It could arise in the distant future. We do not yet know. But the number of stars tells us that the universe has patience. It has had time to experiment. Another quiet implication of star numbers is humility. When we realize how many stars exist, it becomes harder to believe that the universe was created for us alone. That idea feels narrow in a cosmos this vast. Instead, the universe feels like a place governed by laws that operate everywhere, creating stars, galaxies, and worlds wherever conditions allow. We are not the goal of the universe. We are one outcome among many possibilities. And yet, that does not make us meaningless. Meaning does not come from being central. It comes from being aware. Out of sextillions of stars, at least one system produced a planet where matter became conscious enough to ask questions about the universe itself. That is not trivial. That is rare in a different sense. Another way to think about this is perspective. Human life feels long from the inside, but on cosmic timescales, it is brief. Civilizations rise and fall in the time it takes stars to barely change. This contrast can feel unsettling, but it also highlights something beautiful. We exist during a moment when the universe is bright with stars, rich with galaxies, and accessible to observation. Earlier times were darker and simpler. Future times may be darker and quieter. We live in a window where the universe can be studied. That window will not last forever. This makes our curiosity meaningful. Another implication of star numbers is responsibility. As far as we know, life is rare, not because the universe lacks stars, but because life is fragile. It requires stable conditions. It requires time. It requires protection. If life is rare, then preserving it matters, especially intelligent life capable of understanding the universe. Understanding how many stars exist reminds us that while the universe is vast, habitable environments may not be. That perspective encourages care rather than arrogance. There is also an emotional side to this question. Many people feel comfort when looking at the stars. They feel connected to something larger than themselves. Knowing that there are sextillions of stars does not remove that feeling. It deepens it. Each star represents a place where physical laws play out in familiar ways. Gravity pulls, fusion burns, light travels. The universe is not random chaos. It is structured and understandable, even at enormous scales. This understanding builds trust in reality itself. When we look at the night sky, we are not looking at something foreign. We are looking at the same processes that made us possible. This connection matters psychologically. It reminds us that we belong to the universe, not as visitors, but as participants. Another important realization is that knowledge itself is part of the universe. The ability to count stars, even approximately, is a result of stars creating elements forming brains, and brains developing curiosity. The universe learned to count itself through us. That idea may sound poetic, but it is also factual. There is no outside observer of the universe. Every observation happens from within. So when humans ask how many stars exist, the universe is effectively asking that question through a small part of itself. This makes curiosity not just a human trait, but a cosmic one. There is also a limit to what star numbers can give us. No matter how large the number becomes, it will never answer every question. It will not tell us whether we are alone. It will not tell us what the universe ultimately is. It will not tell us why there is something rather than nothing. But it does something else. It gives us context. It tells us that reality is far larger than our daily concerns, yet intimately connected to them. It tells us that wonder is appropriate, and it tells us that asking big questions is not foolish, even when answers are incomplete. As we approach the end of this exploration, it becomes clear that the question, how many stars exist, is not really about numbers. It is about scale. It is about perspective. It is about understanding that we live in a universe rich beyond imagination, governed by simple laws that create extraordinary outcomes. And it is about recognizing that within this vastness, meaning is not lost, it is created. The final step is not to add another zero to the count. The final step is to step outside, look up, and understand that the small number of stars you can see with your eyes represents something far greater than it appears. Behind each point of light lies a universe of depth, history, and possibility. And behind the question itself lies something even more remarkable. At the beginning of this journey, the question sounded simple. How many stars exist in the universe? It felt like the kind of question that should have a clear answer, written somewhere, waiting to be read. A number, a final count, something solid. Now, after traveling through galaxies, time, distance, and uncertainty, that idea feels very different. The most honest answer science can give today is this. The observable universe contains a few sextillion stars, a number so large that writing it down does not make it clearer, a number so big that even saying it out loud does not help the mind understand it. But that answer is not the end of the story. In many ways, it is only the beginning, because every part of that estimate depends on limits of light, limits of time, limits of observation, limits of the human brain itself. We are not counting stars directly. We are inferring them. We are building a picture using light that has traveled for billions of years from regions of space we can never visit, from stars that may no longer exist in the form we see. This means the number is not exact, and it never will be, but this does not make the answer weak. It makes it honest. Science does not aim for perfect certainty when none is possible. It aims for understanding within reality's constraints. When scientists say a few sextillion stars, they're saying something very specific. They are saying this is the scale of reality as best as we can measure it right now. They are also saying that this number may change slightly as tools improve, but it will not suddenly collapse into something small. The universe is not hiding a secret where it suddenly contains only millions of stars instead of sextillions. The scale is real. The vastness is real. Even if every estimate were wrong by a factor of 2 or 10, the universe would still contain more stars than any human could ever imagine directly. Another important point is this. The number of stars we talk about applies only to the observable universe. That is the part of the universe whose light has had enough time to reach us. Beyond that boundary, space may continue. Galaxies may continue. Stars may continue. There could be far more stars beyond what we will ever see, or the universe may be finite in ways we do not yet understand. Science does not pretend to know the answer to that yet. So when people ask how many stars exist in the universe, the most precise version of the question is actually this. How many stars exist in the observable universe at the time whose light reaches us? That may sound complicated, but it reflects reality. The universe does not exist in a way that fits simple questions. Another reason the answer is never final is change. Stars are being born right now. At the same time, other stars are dying. The balance between these processes shifts over time. There was a period in cosmic history when stars formed rapidly. There will likely be a future when star formation slows and eventually stops. So the number of stars at one moment is not the same as the number at another. When we estimate star counts, we are describing an era, a snapshot in a long story. This also means the universe we see today is special. We live during a time when stars are abundant, galaxies are active, and the universe is bright enough to study. Earlier times were darker and simpler. Future times may be quieter and emptier. This makes our moment in cosmic history unusual. Not because it was designed for us, but because we happen to exist during a time when the universe is readable. That fact alone gives weight to curiosity. Another reason the answer is never final is improvement. Every generation builds better tools. Early humans counted stars with their eyes. Then telescopes revealed thousands more. Then galaxies were discovered. Then deep space surveys revealed billions of galaxies. Then infrared and space telescopes revealed stars hidden by dust and distance. Each step expanded the answer. Future telescopes will do the same. They will see fainter galaxies. They will look further back in time. They will refine estimates of galaxy numbers and star populations. The number may change slightly, it may become more precise, but the central idea will remain. The universe is filled with stars on a scale that defies direct comprehension. There is something deeply important about accepting that. Not everything needs to be reduced to something small to be meaningful. The universe does not need to fit into our intuition to be real. In fact, the fact that it does not fit is part of what makes it powerful. When people first learn about sextillions of stars, some feel insignificant, others feel inspired, some feel both at the same time. That mixed feeling is appropriate, because the universe is vast beyond measure, and yet, within it, small pockets of matter have become capable of understanding that vastness. That is not ordinary. It means that complexity is possible. That awareness is possible. That meaning can arise even in a universe this large. Stars do not make the universe meaningful by themselves. Meaning comes from relationships, from understanding, from awareness. And awareness exists. That alone changes how we should see ourselves. We are not the center of the universe, but we are not irrelevant either. We are participants. We are made from material forged in stars. We orbit one star among sextillions. We live on one planet among countless worlds. And yet, we can ask questions that reach across billions of light years. That ability does not come from size, it comes from structure. The same laws that allow stars to form allow brains to form. Gravity pulls gas into stars. Chemistry builds molecules. Evolution shapes nervous systems. Curiosity emerges. All of it follows the same rules. So when we ask how many stars exist, we are not standing outside the universe looking in. We are the universe examining itself from a particular place and time. That perspective matters. It changes the question from one of scale to one of connection. The night sky may look quiet, but it is not empty. It is not distant in the way it appears. Every star you see is part of the same story as you. Every star you cannot see is part of that story too. Most of the universe is invisible to us. But invisibility does not mean absence. It means limitation. And limitation is not failure. It is the starting point of discovery. The question, how many stars exist, has no final answer, because the universe is not finished. Stars will continue to form. Stars will continue to die. Space will continue to expand. Observations will continue to improve. But even without a final number, we already know enough to be changed by the answer. We know that the universe is vast beyond imagination. We know that stars are not rare exceptions. They are a natural outcome of physical laws. We know that complexity is not fragile in the universe, it is widespread. And we know that curiosity is possible within this vastness. That may be the most important discovery of all. So the next time you look up at the night sky, remember this. The few thousand stars you can see with your eyes are not the universe. They are the nearest surface of something far deeper. Behind them lie billions of galaxies. Behind those galaxies lie sextillions of stars. Behind those stars lies a universe still changing, still creating, still unfolding. And within that universe, there is a place where matter learned to wonder. You are standing on it. By now, the numbers may feel distant. Sextillions, billions, light years, galaxies beyond counting. After so much scale, the mind naturally wants to step back and breathe. And that is exactly the right response. Because this question was never only about counting stars. It was about learning how to think beyond ourselves. When humans first looked at the night sky, they saw patterns. They named stars. They connected them into shapes. They believed the sky was close, reachable, and complete. It made sense at the time. With only a few thousand visible stars, the universe felt manageable. But the universe did not change. Our understanding did. With every improvement in knowledge, the universe grew larger. Not because it expanded just for us, but because we finally learned how small our window into it had been. This is one of the most important lessons science teaches. Reality does not adjust itself to human comfort. Humans adjust their understanding to reality. And the reality is this: the universe is not built on a human scale. It is built on a cosmic one. Stars form not because anyone needs them, but because gravity and physics allow them. Galaxies exist not because they're beautiful, but because matter naturally organizes. Under certain conditions, light travels for billions of years not to be seen, but because that is simply how the universe works. And yet, here we are, able to understand it. That fact deserves attention. Out of all those sextillions of stars, out of all those billions of galaxies, at least one small planet developed life that could look outward and ask questions. That is not guaranteed by size. That is not promised by numbers. That is not automatic. It is an outcome, and outcomes matter. Some people hear about the vastness of the universe and feel lost. They wonder how anything can matter in a universe this large. But meaning does not come from being the biggest thing. It comes from being something at all. A single thought matters to the thinker who has it. A single life matters to the life living it. Scale does not erase significance. In fact, the vastness of the universe makes meaning more precious, not less. Because it shows that awareness is not common everywhere. It shows that understanding does not automatically arise just because stars exist. Stars can exist without minds, but minds require stars. That connection is important. The universe can exist without us, but our ability to understand the universe exists only because we are here. This is not arrogance, it is responsibility. Understanding how many stars exist teaches us humility, but it also teaches us value. It shows us that consciousness is something rare enough to protect. Another thing becomes clear when we think about stars in this way. The universe is not silent because it lacks activity. It is silent because sound cannot travel through space, but it is full of motion. Stars orbit, galaxies collide, light moves endlessly. Everything is active, everything is changing, nothing is frozen. That includes us. Human understanding will not stop here. The numbers we use today will be refined. New telescopes will change our view again. The universe will feel even larger to future generations than it does to us. And that is a good thing, because science is not about reaching a final answer and stopping. It is about continuously improving the questions we ask. The question, how many stars exist, did not end with sextillions. It opened doors to deeper questions. How many galaxies exist beyond what we can see? How long will stars continue to form? How common are planets? How rare is life? How long can complexity last in an expanding universe? Each answer leads to another question. This is not failure. This is progress. There is also something deeply human about this process. We ask questions not because the universe owes us answers, but because curiosity is part of who we are. It is a survival trait turned into a philosophical one. Curiosity helped humans find food, shelter, and safety. Later, it helped us understand fire, tools, medicine, and science. Now it helps us understand galaxies and stars. Curiosity scales with knowledge. The more we know, the bigger our questions become. And the universe is large enough to keep answering them for a very long time. One day, humans may no longer exist. Civilizations may fade. Stars will continue their lives whether we watch them or not. But the fact that for a brief moment in cosmic time, the universe was observed, measured, and wondered about is not insignificant. It means the universe produced awareness. That is not something to dismiss lightly. When we count stars, we are not just counting lights. We are counting opportunities for complexity. We are counting engines of creation. We are counting the history of matter organizing itself again and again. Each star is a story. Some stories are short, some are long, some end quietly, some end violently, but all of them contribute to the universe's ability to change. And change is the opposite of emptiness. The night sky may look still, but it is not dead. It is active on timescales far larger than human life. This perspective can be comforting. It reminds us that our problems, while real, exist within a much larger context. It reminds us that the universe has survived far more dramatic events than anything we experience daily. And it reminds us that perspective does not erase pain or effort, but it can soften their weight. There is also something beautiful in knowing that no one will ever see all the stars. Not because we lack technology, but because the universe itself limits what can be seen. Light has a speed, time has a direction, expansion has consequences. This means mystery is permanent. No matter how advanced science becomes, there will always be parts of the universe beyond reach, always regions beyond observation, always questions without complete answers. And that is not a flaw in reality. It is what keeps discovery alive. If the universe were fully knowable, curiosity would end, wonder would fade, exploration would stop. But the universe is built in a way that prevents that. It is open-ended. So when we say the universe contains a few sextillion stars, we are not closing a book. We are placing a bookmark. We are saying, this is where understanding stands today. Tomorrow, that bookmark will move, and that movement is the point. So if someone asks you how many stars exist in the universe, you can give them a number. But more importantly, you can give them a feeling. You can tell them that the universe is far larger than it looks, that the stars they see are only the nearest hints of something vast, that science does not reduce wonder, it deepens it. And you can tell them this: we are not lost in the universe, we are part of it, we are made of it, and for a brief moment in its long history, we are able to understand it. After traveling through such enormous ideas, it is natural for the mind to slow down. Numbers fade, distances blur. What remains is a feeling, a quiet awareness that the universe is far larger than anything we experience in daily life. This feeling is not confusion, it is perspective. When you think about sextillions of stars, the first instinct is often to ask what role humans play in all of this. Are we just accidents? Are we insignificant? Or are we part of something meaningful? The answer depends on how we define meaning. If meaning only comes from being central or dominant, then yes, humans are small. We do not control the universe. We do not shape galaxies. We do not influence the motion of stars. But if meaning comes from awareness, understanding, and experience, then scale becomes irrelevant. A single thought is small, but it still exists. A single life is brief, but it still matters to the one living it. And in a universe with sextillions of stars, awareness is not guaranteed. It is not automatic. It is something rare enough to be noticed. Stars do not think. Galaxies do not wonder. Planets do not ask questions. But we do. That fact alone gives weight to our existence. Another important realization emerges when we stop focusing on quantity and start focusing on connection. Every star follows the same basic rules of physics. Gravity pulls matter together, Fusion releases energy. Light travels outward. Those same rules operate inside your body. The atoms in your bones obey gravity. The chemistry in your cells follows physical laws. The energy in your thoughts comes from the same processes that power stars, just in a different form. This means the universe is not divided into us and everything else. We are not observers standing outside reality. We are patterns within it. The stars are not distant strangers. They are older relatives. Long before Earth existed, stars lived and died. In their deaths, they created the elements that later formed planets. On one of those planets, life emerged. Over time, that life became complex enough to understand where it came from. So when we talk about stars, we are talking about ancestry. We're talking about origins. This changes how the question feels. How many stars exist is not just a scientific question. It is a question about how rich the universe is in the ingredients for complexity, beauty, and understanding. With sextillions of stars, the universe is not poor in possibility. It is overflowing. Another idea worth sitting with is silence. Space is silent not because nothing happens there, but because sound needs air to travel. In reality, space is full of motion. Stars orbit, galaxies collide, light races across the cosmos. Events that would be unimaginably loud if sound could travel through space happen constantly. This means the universe is not calm in the way it appears. It is active on scales and times far beyond human perception. Understanding this can be strangely comforting. It reminds us that stillness does not mean emptiness. Darkness does not mean absence. Silence does not mean nothing is happening. The same applies to our own lives. Sometimes progress is invisible. Sometimes change is slow. Sometimes meaning is quiet, but it is still there. Another important lesson from star counts is patience. Stars take millions of years to form. Galaxies take billions of years to evolve. The universe does not rush. Everything meaningful in the cosmos takes time. This perspective can change how we see our own timelines. Human life feels short, and it is compared to stars, but short does not mean shallow. A brief moment can still carry depth. Stars teach us that duration is not the only measure of value. Some stars burn briefly and shine brilliantly. Others burn slowly and quietly. Both matter to the universe. The same is true for lives. Another realization that often goes unnoticed is responsibility. If the universe is filled with sextillions of stars, that does not mean life is common. It means opportunity is common. Opportunity does not guarantee outcome. Life requires specific conditions: stability, time, protection from extremes. If intelligent life is rare, then preserving it matters more, not less. Understanding how vast the universe is does not give us permission to be careless. It gives us reason to be careful. Because if awareness is rare, then it is precious. Another idea emerges when we think about future observers. Imagine a time far in the future when star formation has slowed. Galaxies have drifted apart. The night sky looks emptier than it does today. Future beings, if they exist, may see far fewer stars than we do. They may not see other galaxies at all. For them, the universe will appear smaller, quieter, and more isolated. They may never know how rich the universe once was. This makes our moment in cosmic history special. We live during a time when the universe is bright with stars, rich with galaxies, and open to discovery. That window will not last forever. So curiosity now matters. Knowledge now matters. Another subtle lesson from star counting is humility in knowledge. Every generation believes it understands the universe better than the last, and every generation is partly right and partly wrong. Ancient humans believed stars were fixed lights. That was wrong, but understandable. Early astronomers believed the Milky Way was the entire universe. That was wrong, but reasonable given their tools. Today, we believe we understand the scale of the universe. And we do, better than ever before. But future generations will likely look back and see limits in our understanding too. This is not a weakness. It is how knowledge grows. The universe is not something to be mastered. It is something to be approached gradually, with curiosity and humility. Another important point is that numbers alone do not capture beauty. Knowing that there are sextillions of stars does not replace the feeling of seeing one clearly on a dark night. Science does not remove wonder. It adds layers to it. When you see a star and know it is a massive sphere of plasma burning for billions of years, the sight becomes richer, not poorer. When you know that its light has traveled for centuries to reach your eyes, the moment becomes deeper. Understanding does not kill mystery, it refines it. And mystery is not ignorance, it is awareness of limits. That awareness keeps curiosity alive. Another reflection worth making is about perspective and peace. When people feel overwhelmed by personal problems, looking at the universe can help. Not because it makes problems disappear, but because it places them in context. The universe has survived supernovas, galaxy collisions, and cosmic expansion. It has endured events far more extreme than anything we experience personally. This does not minimize pain. It offers balance. It reminds us that change is natural, struggle is temporary, and perspective can soften intensity. Stars teach patience. They teach endurance. They teach that transformation is part of existence. And finally, there is the simplest truth of all. No matter how many stars exist, no matter how large the universe is, the experience of wonder happens locally. It happens in a single mind, on a single planet, under a single sky. The universe does not experience itself all at once. It experiences itself through moments like that, through someone standing outside at night, through someone asking a question, through someone choosing to learn. So when you ask how many stars exist in the universe, remember this: the universe does not need you to understand it to exist. But your understanding adds something unique to the universe. It adds awareness. And awareness, in a universe this vast, is not small. It is rare, it is meaningful, and it is worth protecting. That is the quiet truth hidden behind the numbers. Not how many stars exist. As this journey stretches on, something subtle happens. The universe begins to feel less like a distant object and more like a background presence. It stops being just out there and starts feeling quietly connected to everything around us. This is not because the universe has changed, it is because our way of seeing it has changed. When we first hear about sextillions of stars, the number feels abstract, almost unreal. But after sitting with it long enough, the number fades into something else. A sense of scale, a feeling of depth, a recognition that reality is layered far beyond the surface we normally live on. Most of our lives happen at a human scale. We think in hours and years. We measure distance in steps and kilometers. We care about things we can touch, see, and influence directly. The universe does not operate at that scale. Stars are born over millions of years. Galaxies change shape over billions. Light travels distances so large that entire civilizations rise and fall while it is still on the way. This difference in scale can feel uncomfortable at first, but it can also be grounding. It reminds us that not everything needs immediate answers. Not everything needs to move fast. Some things unfold slowly, patiently, without urgency. The universe has no deadlines. And yet, within that vast patience, brief moments like ours still matter. Another quiet realization comes when we think about uniqueness. With sextillions of stars, it might seem like everything must be repeated endlessly. Countless suns, countless Earths, countless lives. But scale does not guarantee sameness. Even if many stars resemble our sun, their histories differ. Their environments differ. Their planets differ. No two systems share exactly the same conditions. Variation is built into the universe. Stars may be numerous, but identical outcomes are not guaranteed. This means that even in a universe filled with stars, uniqueness still exists. Your experience is not erased by numbers. It is defined by conditions that came together once, in one place, at one time. Another thought follows naturally from this. If stars are so common, why does life feel fragile? The answer is that stars create opportunity, not certainty. Stars provide energy. They create elements. They allow planets to form. But life requires balance. Too much radiation, and life fails. Too little energy, and life stalls. Too much chaos and stability is lost. So while the universe may be rich in stars, it may still be selective in where life can survive. This makes life precious, not because the universe is small, but because the conditions for awareness are narrow. This understanding encourages care. Care for our planet, care for life, care for knowledge. Because even in a vast universe, fragile things matter. Another lesson from star counts is that not everything meaningful leaves a visible trace. Most stars will never be seen by any observer. Their light will travel through space without ever meeting eyes or instruments. They will live and die in silence, yet their existence still matters to the universe's structure. Their gravity shapes galaxies. Their deaths enrich space with elements. Visibility is not a requirement for importance. This idea applies closer to home as well. Many meaningful actions go unnoticed. Many lives are quiet. Many contributions do not receive recognition, but they still shape outcomes. Stars teach us that influence does not require attention. Another idea that emerges is acceptance of limits. There will always be stars beyond our reach, regions of the universe we cannot see, questions we cannot fully answer. This is not a flaw in science, it is a feature of reality. The universe is larger than any method we can create, and that is okay. Accepting limits does not mean giving up. It means understanding where effort is meaningful. Science does not need total knowledge to be valuable. It needs honest inquiry. An inquiry does not end when answers are incomplete. It continues because they are. This is why the question of how many stars exist remains open-ended. Not because science is weak, but because reality is deep. Another reflection comes from thinking about observation itself. Every star we count is known only through light, tiny packets of energy that traveled across space for years, centuries, or billions of years. That light carries information about temperature, about motion, about composition. Without light, stars would be invisible. Without interpretation, light would be meaningless. So every star count depends on both nature and understanding. The universe provides signals. We provide meaning. Neither works alone. This partnership between reality and awareness is quiet but profound. It means knowledge is not something we extract from the universe. It is something that forms at the boundary between the universe and the observer. That boundary is where curiosity lives. Another thing to consider is continuity. Stars you see tonight were seen by ancient humans too. The same light reached their eyes. The same patterns filled their skies. They did not know what stars were, but they felt wonder. They felt curiosity. They felt connection. Today, we understand much more, but the emotional response remains similar. Wonder survives knowledge. In fact, knowledge often deepens wonder rather than replacing it. This continuity across generations matters. It shows that curiosity is not a modern invention. It is a human one. Stars have always invited questions. Another realization comes when we think about endings. Stars die. Galaxies change. The universe will not always look like it does today. This does not make existence tragic. It makes it dynamic. Everything meaningful exists within time. Stars teach us that endings are not failures. They are transformations. When stars die, they create new elements. Those elements form new stars and planets. Endings enable beginnings. This perspective can change how we see change in our own lives. Loss is not always absence. Sometimes it is transition. Another important idea emerges when we think about future understanding. Future humans or other beings may understand the universe far better than we do. They may count stars with greater precision. They may discover structures we cannot imagine. But they will still inherit mystery. No matter how much is known, there will always be something beyond reach. This ensures that curiosity never ends. And curiosity is not just intellectual, it is emotional, it is motivational. It drives exploration, it drives learning, it drives connection. Another quiet truth is this: the universe does not need to be understood to exist. But understanding adds depth to existence. The stars shone long before humans existed. They will shine long after we are gone. But for a brief window, they are understood. That window matters. It represents a moment when the universe became aware of its own scale, and that awareness happened locally, quietly, without fanfare. It happened when someone asked a question, someone like you. This brings us back to the simplest image: a person standing under a night sky. Nothing about that image has changed for thousands of years, but everything about what it means has. The sky is no longer a ceiling. It is no longer a mystery without context. It is a map of history, a record of time, a hint of vastness, and yet it still invites the same feeling: wonder. Not because we do not know enough, but because what we know is so large. So when you hear that the universe contains sextillions of stars, let the number fade. What matters is not memorizing it. What matters is what it does to perspective. It reminds us that reality is larger than routine. It reminds us that patience exists on cosmic scales. It reminds us that awareness is something rare and meaningful. And it reminds us that asking questions is not small. It is how the universe learns about itself. That is the quiet power hidden behind the question. Not the count of stars, but the act of counting at all. Before you leave, pause for a moment, not to remember the numbers, not to recall the estimates. Just pause. Because after everything you've heard, the most important part of this journey is not how many stars exist. It's what that question does to the way you see the world. Tonight, when you look up at the sky, you may still see only a few scattered points of light. The sky will look quiet, familiar, almost empty. But now you know that what you are seeing is only the nearest surface of something unimaginably deep. Behind every star you can see, there are millions you cannot. Behind those millions, there are galaxies beyond counting. And beyond those galaxies, there may be more universe than we will ever reach. And yet, here you are, on a small planet, around a single star, in one quiet moment of cosmic time, able to understand all of this. That alone is extraordinary. The universe did not have to be understandable. It did not have to follow simple laws. It did not have to allow matter to organize into stars, planets, and life. But it did. And out of sextillions of stars, at least one place produced beings curious enough to ask where everything came from. That curiosity matters, because the universe is vast, but awareness is rare. Stars are common, understanding is not. So the next time life feels small or routine or overwhelming, remember this: you are part of a universe capable of creating stars by the sextillion, and you are made of the same material that once burned inside them. You are not separate from the cosmos. You are a continuation of it. If this journey made you see the night sky differently, take a moment to show your support. Subscribe to the channel, like the video, and share it with someone who loves big questions. It helps these stories reach more curious minds. And if you want to keep exploring, more journeys are waiting. Stories about space, time, and the universe we live in. Until then, keep looking up, because the stars are still there, and the questions are far from finished.